Welcome to next lesson on dilations and similarity. For this video lesson, we're going to learn how to enlarge or dilate an image on a coordinate plane. Secondly, we'll be able to prove that a dilated image is similar to its original image. Some of the materials that will be needed here will be a graph paper, ruler, pencil. And for this lesson, you need to be set up the graph paper. Maybe not exactly this way, but you want to set it up using the entire sheet of graph paper in a portrait position, drawing your y-axis by counting over 3 lines from the left edge of your paper, maybe the x-axis, by counting up 3 lines from the bottom of the paper. You are only going to be needing quadrant 1 for this activity. And after your papers are set up, you need to plot the 3 points for the triangle that we'll be using as an original image. A 1, 1, B 2, 1, and C 1, 3. And you'll be connecting these points. Your graph paper should look something like this. And next we're going to dilate this original image by enlarging it. This is done by multiplying all the points of our original image by a certain factor. For this lesson, let's enlarge by a factor of 4 by multiplying all the points by 4. Our new enlarged image points would be A prime 4, 4, B prime 8, 4, C prime 4, 12. Connect these points as well, and your paper should look like this. With our original image and enlarged dilated images plotted on your grid, we'll need to begin to compare them. Let's look at the relationship or the ratio of the legs of the original image. Line AC is 2 units and line AB is 1 unit. So the ratio of AC to line AB is 2 to 1. Looking at the enlarged image now, we can see that line DF corresponds to line AC and line DE corresponds to line AB. The ratio of DF to DE would be 8 to 4, which can be simplified to 2 to 1. This tells us that proportions of the 2 images are equal, which means that the 2 images are similar to each other. However, let's follow along a bit further in this lesson's exploration to check for angle congruency. There's a rule that says similar shapes have equal angles as well as proportional sizes. Let's take another look at our 2 images and determine the type of translation or slide which would be needed to move point B of the smaller image to the corresponding position of point E on the larger triangle. In this video, if we slide to the right and slide up 6 units to the right and 3 units up, should put point B in the corresponding position top of point point E. Our translation would be written like this: x, y becomes, or moves to, x plus 6, y plus 3. I've noted the slopes of both images as another measure of similarity. Both slopes are m equals -2. Let's see what we find out as we slide our original image to the right by adding 6 to the x and up by adding 3 to the y. Moving over 6 to the right and up 3 on the y, and we can see that the smaller triangle is sitting perfectly in the position where the angle E was. What this shows us when we look at the 2 images is that what we knew algebraically before moving the original image. We have a line running through point E at a slope of -2. This creates an angle E when a measure is taken from a second line parallel to the x-axis. We also have a line running through point B at slope of -2. This creates the same angle as E when a measure is taken from a second line parallel to the x-axis. The same proof can be shown if you were to carry out a dilation, which was a reduction in size of an original image. You would slide an original point image point into its corresponding reduced image point and see the corresponding angles were congruent. This concludes our tape. Thank you.